moving on to the next example, we have this function x squared plus 4 all over x to the power 3 minus 3, and then that's all to the power of 5, and we have to find the derivative. First thing to realize, notice how this is a composite function because we have a inner function, the x squared plus 4 over x to the power 3 minus 3, and then that whole inner function is to the power of 5. So the inner function is this rational function here, and then the outer function is like x to the power of 5, or this whole function to the power of 5. So we can apply the power of a function rule, or more generally the chain rule, to find the derivative of this. So then to find the derivative, let's start by applying that chain rule. So taking the derivative of that outer function, we bring the 5 down, keep the inner function the same, subtract 1 from the exponent, and now we have to find the derivative of that inner function here. Because if you remember, if you have a function that is a composite function, well, the derivative of it is going to be the derivative of that outer function by keeping the inner function the same, which is what we did here. The outer function was to the power of 5, so we brought the 5 down, subtracted 1 from the exponent, kept that inner function the same, and now we have to multiply it by the derivative of that inner function. So this here is the chain rule, so we have to find the derivative of this inner function, this rational function here, and to do that we can apply the quotient rule. Then applying the quotient rule on that inner function, we take the derivative of the top function, which is just 2x, times the derivative of that bottom function, which is x to the power of 3 minus 3, and then we subtract that top function, x squared plus 4, times the derivative of that bottom function, which is 3x squared, all over that bottom function, x to the power of 3 minus 3 to the power of 2. So notice how we applied the quotient rule within the chain rule, and I'll get back into explaining what I mean by that. And now let's try to simplify this a little bit more. So then distributing everything in the bracket here in the numerator and then simplifying all the like terms, you would end up with negative x to the power of 4 minus 12x squared minus 6x in the numerator. And then the denominator stays the same, and then this term here stays the same as well. So can we simplify this any further? Well, notice, number one, how we can factor out an x from the numerator here. X is a like term. And also notice how this x to the power of 3 minus 3 is a like term as this x to the power of 3 minus 3. So let's see if we can somehow combine them. So to simplify this even further, I'm going to do a couple of things. First thing I did was I distributed this exponent to the numerator and the denominator here, because if you remember exponent laws, if you have a fraction to the power of x, that's the same as the numerator going to the power of x and the denominator going to the power of x. So this x squared plus 4 is to the power of 4, and then this x cubed minus 3 is to the power of 4 as well. And then over here in the numerator, I just factored out a negative x from this expression here, and I'm left with x to the power of 3 plus 12x minus 6. And now we can multiply everything. Basically, we would multiply all the numerators together and then all the denominators together. And notice when we multiply the denominators together here, these bases for these exponents are the same. So when we multiply these two, we can just add the exponents. So then when we combine all this, we end up with this big simplified derivative. Now, one thing I want to note from the last take, I had a negative 6 here before. It should be a positive 6. So I changed that here and changed that here as well, because when we take out a negative x from this expression, all the signs change. So this negative 6x would change into positive 6. And yeah, this is the simplified derivative. So basically this negative x I brought to the front, so we got negative 5x in the front. This x squared plus 4 to the power of 4 stays the same. This expression in the bracket, x to the power of 3 plus 12x plus 6 stays the same as well. And then in the denominator, I combine this x to the power of 3 minus 3 to the power of 4 and that same bracket to the power of 2. Because they're the same base, we're multiplying, we can add those exponents. So that ends up being x to the power of 3 minus 3 to the power of 6. Now, one more recommendation I want to make when you're doing these types of questions, even though the question never specifies for you to do so, is I would write out a statement like this at the end of each question. So in this question, we applied the quotient rule within the chain rule because we had to first apply the chain rule to this composite function, and then to find the derivative of that inner function, we had to apply the quotient rule. So the quotient rule within the chain rule. In the example previous, we applied the chain rule within the product rule, but it's also possible to do the opposite. You can apply the product rule within the chain rule, or the chain rule within the quotient rule, depending on the type of function you're given. So I would write down these sentences at the end of each question just so you better understand what you're doing, what steps you're taking, so then when you get to the test, you'll be able to do the questions a lot more efficiently, a lot more quickly. You'll be able to see scenarios a lot more quick, and you'll minimize your chances of making a mistake because you ran into these scenarios and really made sense of them in your head beforehand. Yo, what's up guys? Thanks for checking out my channel. Hopefully you got some value from the video you just watched. If you did get some value, big favor to ask you, please like this video and subscribe to the channel. Any questions, any recommendations on things you'd like to see, please leave it in the comments section. Also check out the description box below for links to material and content related to the video you just watched. Peace out.